Time travel is one of those science fiction tropes that seems impossible, but it's actually possible. And we have the technology to do it right now if we wanted to. But here's the catch. The only time travel we can currently do only works in one direction, forwards. So if you want to go back in time, you'll need to build a time machine. But for those of you who just want to hop in your spaceship and fly off into the future, strap in because you're about to get there faster than you think. You see, time is relative. It's not constant like gravity or the speed of light. What appears to be a tick-tock of the clock is really just an agreed-upon measurement. The reason that we agree on this particular measurement is because the Earth's rotation causes a consistent change in our location relative to the Sun. This consistent change causes predictable patterns in our environment, so we can use it to create our measurements of time. For example, every 24 hours the sun rises and sets in our location on Earth. So we divide that day into 24 hours, then each hour into 60 minutes and each minute into 60 seconds. And since the Earth rotates almost exactly once per day, we end up with approximately 24 hours in a day, 60 minutes in an hour and 60 seconds in a minute. If the Earth rotated 3 times per day, then our timekeeping system would also rotate 3 times per day. That's because it's all relative. And so is the passage of time. How fast time passes depends on your relative motion, or in other words, how fast you're moving relative to something else. And no matter how fast you move relative to something else, you always measure your own motion as being still. Because if you're in a spaceship and you throw a ball straight up in the air, it will appear to go up and then come straight back down to you regardless of how fast the ship is moving through space. In fact, if you were in a perfectly enclosed room and you could look out a window or see anything else, you would be able to tell if you were at rest or if you were flying through space at a constant velocity. This is called the principle of relativity, and it's why Einstein concluded that time is relative. Imagine you're standing on a platform waiting for a train. You see a friend get onto a train car that's moving very quickly. You say goodbye and your friend gets on board. Your friend looks back at you as the train accelerates forward and sees you standing on the platform getting smaller and smaller. They also notice that the platform itself is getting smaller and smaller. From their perspective, the train is staying the same size, but the platform is getting smaller. From your perspective, however, the train is getting smaller too. So what's really going on? Well, it comes down to how fast you're moving relative to something else. According to Einstein's theory of special relativity, the faster you move through space, the slower time passes. Now we typically don't notice this effect because we don't usually move fast enough for it to be significant. But if you were to approach the speed of light, time would slow down so much that you would effectively stop aging while time continued to pass normally for everyone else. Astronauts on the International Space Station are actually a few minutes younger than their counterparts on Earth due to the effects of time dilation. Although they're not moving nearly fast enough to make any kind of significant time difference. If you wanted to drastically change the passage of time, you'd need to move a lot faster, like close to the speed of light. In fact, to travel 1 year into the future, you'd need to travel at 99999999999999999% the speed of light. At that speed, time on Earth would pass 100 times faster than it would for you. So you'd only experience 1 year passing while 100 years passed on Earth. Now, that's not the only way to travel in time. Space also warps time. Gravity pulls time towards it like a rubber sheet. So the closer you are to a massive object, the slower time passes. It's the same reason that the further away from Earth you go, the younger you get relative to people on Earth. So if you wanted to travel into the future, you could also hang out near a black hole where time slows down dramatically. However, you'd only be able to travel into the future in this scenario, not the past. But hey, we're just talking hypotheticals here. We're just spitballing. Actually traveling into the future by slowing down time around you is probably the most feasible way of actually traveling in time. And we have the technology to do it today. All you need to do is get really, really, really rich. Then use that money to build a giant spaceship capable of reaching near light speed. Then use that spaceship to get really, really, really far away from Earth. Eventually, when you turned around and came back, you'd find that centuries or even millennia had passed on Earth, but only a few years had passed for you. Hey, if anyone wants to fund my time travel, I'm available. Coming up next, why does time seem to go faster as we get older? Click here to learn more or click here to watch this video instead. Don't forget to subscribe so you're notified every time we upload a new video.